Hello. Today we're going to be talking about graphing a system of equations. Now we've done this before where we've just taken two linear equations and we've solved them either through graphing by substitution or the elimination method. Well, here you can see that we have not two linear equations, but we have one parabola. We have a parabola and then we have a line. So we're going to try to figure out at what point do these things intersect if we were to graph them, or rather what pair of xy combination or combinations do they both share within their solution sets. So in order to solve this system of equations, since I know that 2x plus 13 is equal to y and x squared plus 5x plus 9 equals y, I can substitute this number in place of y since they're both equal to that. So I can write this as 2x plus 13 equals x squared plus 5x plus 9. And all I did was some substitution there. All right, now essentially I have a quadratic equation that I need to solve. So anytime I want to do that, I get it equal to 0. So I subtract 2x on both sides. I'll also subtract 13 on both sides. And so 0 equals, and I get x squared plus 3x minus 4. And now to solve this, I always look, well, I can't get x squared by itself, so my next try is factoring. And so we'll see if factoring is going to work. So I open my two sets of parentheses. GCF is 1. So I'll have x and x, and I need numbers that multiply to make negative 4. Got to multiply to negative 4. Got to add to make positive 3. And let's see, we'll get plus 4 and minus 1 that certainly do that. So when I solve this, x plus 4 equals 0, or x minus 1 equals 0, x is equal to negative 4, or x is equal to positive 1. So I do have two times that these things will cross, it looks like, where x is either negative 4 or negative 1. So let's figure out what the y values are when that happens. So let's plug in negative 4 first. And the easy way to do this is if I just plug it into the line. So y equals 2 times negative 4 plus 13. That means I have y equals negative 8 plus 13, so y is equal to 5. So my first ordered pair, when I plugged in negative 4, my output was 5. So there's one solution to this system of equations. So let's try the other one. If I plug in 1, so y is equal to 2 times 1 plus 13, which means I have y equals 2 plus 13, or y equals 15. So this time I plugged in the number 1 and got the result 15, and there's another way to look at this. If I were to graph this, if I were to just kind of make a rough sketch of this, well, we know that we're going to have a y-intercept of 9. My vertex, the x-coordinate, is going to be sitting at negative 2.5 because I'm going to take negative 5 divided by 2 times 1. It's not going to cross the x-axis, so it's going to kind of look in general like that. Okay, there's a basic sketch of it. This right here is where we cross the y-axis at 9. Okay, let me draw the line then. For the line, we know that we have a y-intercept of 13 and a slope of 2, so we're going to come through like this. There we go, that's slightly better. So right here is the number negative 4 comma 5, that's that ordered pair. Up here we have 1 comma 15, and that's what it looks like if we were to graph it, just in general. I didn't do anything terribly great on that. So what does it look like when we graph these types of figures? What are the maximum times that they could cross? So if I were to look at a parabola crossing another parabola, well, here's the shape of a parabola, and assuming that it's not just sitting right on top of it, it could potentially cross something along the lines like this, so it would cross twice. There's one, there's one. So it has a maximum number of intersections of 2. All right, let's look at a parabola and a circle. So if I were to draw a parabola, there's a rough sketch of that. Here is a circle. And so you could see how here's 1, 2, 3, 4. It could possibly intersect up to 4 times. If I were to take a parabola and a line, well, we just did one of these. This is really the best you're going to get. 1, 2, so 2 intersections. Okay, we already did parabola and circle, we already did parabola and line. How about a circle and a circle? Well, if I were to draw here's one circle, and then let me draw another one, and again, we're assuming they're not going to overlap here. That's probably the best I can do there. 1, 2, so 2 intersections for that. If I take a circle and a line, so there's a circle, and let me draw a line through it. 1, 2 intersections there. Okay, we've already done a circle and a line. And then you should know this one. If I take 2 lines, here's one line, here's another line, the best they can do is 1. And of course, any of them could be less than that. They may intersect in different ways in this. Again, this is just the maximum number of times that they could cross. And we are done.